Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. I can see only 13 people at the moment. By the way, who's that? Wan Muhammad Lokman.
Yes, sir.
Are you always early in the morning? Are you on campus or are you at home?
At home.
At home, ya. Awal bangun subuh apa semua lah.
Pas subuh tak tidur tu.
Kau tu jenis tak tidur malam ni.
Tak saya tidur. Cuma pas
Tidur,
subuh saya tak tidur lah.
Betul lah. Sebab ada juga pelajar yang mana kadang-kadang jenis tak tidur tu yang saya risau, pagi-pagi tak tidur. Pada malam main game.
Juga tapi
Okey, boleh nampak skrin saya tak?
boleh sir.
Okey, terima kasih.
Nampak saya nampak.
Nampak ya. Okey, sementara kita tunggu kawan-kawan yang lain, dia dah naik 2023 juga dah, Inventor Nastran 2023. Jadi kalau professional pun, Inventor professional, saya tukar yang ni. Saya cadangkanlah kalau komputer boleh ambil, update je lah ya. Dia ada update button tu, dia ada satu Autodesk development app tak, dia boleh control apa dia punya install. Okay, you can see that the icon change a little bit. I think that's not quite normal for commercial company. They always like to renew their logo lah, and then version. It's almost the same, yeah. It's almost the same. I'm going to start anyway, because we having budgetary meeting and all that in the faculty. Alright, I will begin the start recording. And the rest of you still who's not joining can watch the video later. Assalamualaikum warahmatullahi wabarakatuh. Today is Thursday, 31st of March 2022. This is week 4. The time now 8:06. I will begin this morning lesson as a recorded. Yeah. At the moment, I can only see 19 people, including me, in the session. First of all, I would like to highlight that Autodesk Inventor and Autodesk Inventor Nastran has updated their latest version. Now is version 2023 as of March 2022. Yeah, so they normally use a year advance like that. Yeah. So you can see that the one that you have just installed, I believe will be the version 2022.2, which is November 2021. Those who wants to remain in the previous version, that's okay. Yeah, but because of this is education license is free for students, why not you update, yeah, if you have the capacity, computer capacity to. Let's look at the tutorials. I think it's just the same. Yeah, nothing much has changes. They're not changing the tutorial things like that. It's just the cover page of that. For today's lesson, we'll go backwards a little bit into quick start. Yeah, quick start tutorial. This one. Yeah, I'm going to click share email. I'm going to share in the chat. By the way, all those shared links and whatsoever is always available together with the recordings. Yeah, if you go into the Microsoft team, our group team, and then you can track down recording for each week. That's why I normally, when I started the recording, I will say the date, time, and the week as well, so that it's easy for you to track down. And then whatever meeting chat came out, that record, it will also be included in that log file. All right, let's go back to here. So this is actually a new user quick start, and then I will go actually for the linear static stress of welded steel hanger. Right. Step one, you can always watch the videos first. Let me just quickly just play a little bit of the video.
Flaws in the design process can result in costly recalls or much worse.
I will encourage you to watch this video later on, during your own leisure time as a study, because some of the questions or a lot of the informations are available within this video itself. All right, so that is one video, which is Autodesk Inventor Nastran story.
As engineers, you strive to minimize failure and build the best products for your customers. Simulation tools give you the insight to deliver safer, higher quality products to market faster at less cost. Now, with Autodesk Nastran in CAD, there is a better way to use advanced simulation. Your workflow is streamlined with Autodesk Nastran in CAD, which embeds the powerful FEA simulation capabilities of the Autodesk Nastran solver directly into Autodesk Inventor and other CAD systems. This seamless CAD integration gives you the immediate design guidance you need, even at the earliest stages. By preparing the simulation in CAD.
By the way, can I talk to Cik Muhammad Amir? Cik Amir?
Yes, sir.
You already completed until this tutorial?
Yes, sir.
Yeah, tak apa ya. It's okay, just follow on. Thank you.
Sir, yang komen tu yang beam tu
Ya.
Yang beam tu saya dah buat dah, sir.
Okay. Tapi awak ada buat yang propeller ni kan?
Ada buat juga.
Tak apa. Okay, good. Okay, thank you.
Yang beam tu nak kena hantar juga ke?
Ya?
Yang beam tu nak kena hantar juga ke gambar dia?
Kalau ada, hantarlah.
Okay, sir.
Rapidly exploring how your designs perform without recreating the setup for each iteration. Autodesk Nastran in CAD uses the industry-recognized Autodesk Nastran solver, trusted for its speed, accuracy, and verification. Rigorous validation using NAFEMS, the Autodesk Physical Testing Labs, and other published benchmarks ensure the accuracy you need for dependable results. Autodesk Nastran addresses a wide range of simulation types, including linear and non-linear stress, dynamic response, steady state and transient heat transfer, thermal stress, fatigue, buckling, and composite laminate materials. To support these capabilities, Autodesk Nastran in CAD includes an extensive set of material models, including plastics, composites, and metals. The licensing system in Autodesk Nastran in CAD makes it easy to share the software.
Okay, so this video is essentially just to introduce the capacity and capability of finite element analysis. Yeah, of course, in this case, we are using a commercial brand called Autodesk Inventor Nastran. There are other commercial brands, like ANSYS, Abacus, and so on and so forth. Just like when you're driving a car, of course, there's Mitsubishi, Toyota, Honda, Rover, whatever other brands. So it just happened that this Autodesk Inventor has a licensing agreement with the IPTA Institut Pengajian Tinggi Awam, so that we can have access for it freely, yeah, as long as you're a student. And especially with the situation as it is right now, you're still at home, then students have access to the software itself. The software itself is very expensive. I think at the beginning there was a couple of students who wrongly clicked the commercial one. You can see what's the actual price, yeah, required for yearly subscription of the. It's quite expensive in USD, yeah, running up to 6,000 plus in USD, 20,000 over per license. So anyhow, this is free because you are virtue of your registration with the university. However, with regards to the computing power or the laptop or PC, that is very challenging. Yeah, of course, there was a recent incident with regards to one particular IPTA where there was an argument with regards to access to laptop, things like that. Yeah, then become viral and so on and so forth. Yeah, for running as this class, I fully understood the situation. If you have problems or cannot access, you need to tell me as soon as possible. We need to think a solution because we're already in week 4. All right, so that's the story. If you go to the process, let me just click. You can always access this video on your own later on and then watch and rewatch the content. Yeah, I already put the link. And then let's just watch the process, where to begin.
In this video, we discuss the Autodesk Nastran in-CAD simulation process or workflow. Simulation models begin in your CAD application.
Okay, if you look at the screen, it listed 11 steps, yeah? Create an open CAD model. Let me just make it larger. Create an open CAD model, enter in CAD environment and define analysis settings, define material and element properties, define contact pair, mesh the model, create and cases and subcases coordinate system, apply constraint and load. If you want to go to nonlinear options, you need to edit the material and run the emulation, evaluate the results and generate a report. So that's what this video is all about. Yeah? So you can have a look at it. Don't worry, the video probably was prepared using Autodesk Inventor Professional 2016. Even though here it says 2023, I think it's still valid. Yeah, they just used an old video. Then it can be you can follow through the video later on. Okay, and then what we have here is step 2 for the new user is a complete quick start tutorial. Well, when we started, we jumped straight away to tutorial and self-paced trainings. So never mind. I purposely do that. We just straight away to when to do bath fitting. Yeah. So this video is still valid. Yeah, you need to have a look. And then if you look here, yeah, there is a link for the tutorials which we already gone through. Oops, mana tadi? Quick start tutorials. Okay. Quick start tutorials. Okay, there is a video about quick start tutorial introduction. Yeah, a little bit on the way that you need to navigate through the software options. What is important for this morning is actually this one. Yeah, share. For this week, for today's lesson, you need to complete this tutorial. Yeah, quick start. I will send this one. 2 days tutorial 31st March 2022. Alright, it's called, the tutorial is called linear static stress analysis or welded steel hanger. So what is different about this is that it's an assembly. So far, we have performed analysis based on single component. Yeah, based on single component. Now it's an assembly. If you can see here, there is a bracket, there is bolt and nut, and then there is a U-bolt. All right, in this tutorial, we complete a linear static analysis of welded steel hanger, of which 600 Newton downward load is applied. So it explains how much load is applied. However, you need to have a new features in the finite element analysis, which is a contact, because we have an assembly. So that assembly require contact. Yeah, for example, if you have bolt like that, you have one component. Can you see my screen? So you have a bolt component. Previously, we always done a single component. Let me just take this out. Meaning that we just do single component like that. There is no other component. If you have a load, tensile or compression, bending, things like that, it's only one load. Now you have a secondary component, at least in this case when I'm trying to show you in the video, in this lesson, is that we have a secondary component. And then that's what's normally is an actual reality component is. So you need to contact. So there is a contact between part number 1 and part number 2, or in this case, the bolt and the nut. So that's what this analysis trying to impart or to deliver to you, is that there is a new feature called contact. And then fully fixed X direction. And then you need to sort of like split the surface in the CAD model to provide partial surface for. So a lot of time, if you can see here, the actual load actually applied on a particular surface region of the U-bolt. Yeah. So there is an activity a little bit on how to split the surface. If you, before to start the tutorial, you need to click this link. A lot of people sometimes can't find the file because they skip all those early explanation. You perhaps missed out on certain links. Yeah, I'm going to put here. So file for this tutorial. File for this tutorial. Okay, so you can download this zip file and then you can start work. Yeah. All right, so go back to this. So again, for each tutorial, there must be an objective, outcome of that. Yeah. So determine vomisis, determine displacement, vomisis stress, and then safety factor. Yeah, it talk a little bit about material, the material for U-belt, and the well itself. Yeah, and then mesh parameter, well, things like that, and then contact. So contact type. Just try to do the tutorial first. I will later on, once you have done, we can discuss contact and contact generation. There is a little bit on contact tolerance. Yeah. Constraint. You already done a few tutorials. You already know what is fixed and how to Tx or Ty, Tz. And then we have a force of the load, a force of negative 6,000 Newton in Y directions going downwards. And then they talk a little bit that the U-rod surface, which is this one, the U-rod. has been split at the load corner plus minus 45 from the bottom dead center of the band. So basically they just take a chunk of that surface and split it so that the load is properly applied as it, yeah. If not, if you do not have that split surface, if you click this adjacent surface to the U-bolt, everything will be loaded up to the bolt, which is not how we load in reality, in real life. And then you have all the steps, open the model. Yeah. In here, they shown you both the steps and the video. You can play the video as well. Yeah. For example, like this. There is no voice, but there is a step by step. You can watch where the cursor are happening. Yeah. And then you can go to define material and properties, mesh the model. Yeah, mesh the model. There is a mesh option. Watch out for the well definition. And then you need to create contact within the well and the body and surface contact. This is an auto generated. There is an option later on when we do individually selected. Apply the constraint. Here the constraint. So at the fixing hole, so we constrain at the fixing hole, and then there is one more surface that we need to constrain. Yeah. All right, and then apply the load. So there is a load here, 1B. So there is a step by step. Yeah. So you need to apply the load. And then that's ready for running analysis, and then solution complete, and then finally evaluate stress strain for the analysis. The interface might be slightly different because this was prepared in version 2016. I think most of you has already gone into 2022. And even like I mentioned early on in the early part of this lecture, that we went to 2023 already. And then finally, there is some analysis or evaluation for factor of safety. Yeah? So we can do factor of safety and then look at whether the bracket and the U-bolt can carry, sustain the load applied. Yeah. So that's what it is. Yeah. Quick start tutorial. I already give you the link. And then the other thing is that essential skills video here. Yeah. Essential skill video here, overview. I will share. This one also part of the learning process that you need to look at it in your free time. Yeah, because the learning process not only synchronized, meaning between interaction between me as a class instructor and you as a course participant, but the learning instruction can be done asynchronous. Asynchronous meaning that even though you're not sitting in front of me or technically online together, you can always learn this during other time, yeah, at your own pace. So it's called a blended learning. Yeah? So it's an combined learning of watching a video, listen to my explanation, question and answers, like what we have done. Question and answers, either we can do online video like this, online session like this, or question and answers during our interaction in the Microsoft Teams in the chat box itself. Yeah. All right. If you go to here, there's a few videos that you need to watch. Overview, efficient modeling, linear buckling analysis. We need to do that because later on we're going to have to do linear buckling, fatigue, nonlinear, and nonlinear transmission. So let's just watch one video quickly, just to have the introduction.
Welcome to this demonstration of using bolt connectors in the Autodesk Nastran InCAD.
You can see now the assembly getting more complicated. Yeah, last time we just have one line or one beam. Now it's an assembly. So that's why you need to do the new user quick start linear static welded hanger tutorial first, yeah, as a continuation from your earlier part of the tutorial. You can see now the parts are very complicated. This looks like some sort of geared and differential, maybe, yeah.
Solver embedded in Inventor. During this video, we're going to run an analysis to find out whether the bolts will outlast the gear or the hub under extreme loading conditions. Taking a close look at the design, we have several bolts, nuts, and washers being used to fasten the components in the assembly. There are a couple approaches that can be taken to set this analysis up. First, we can analyze the bolts as they are and gain some knowledge of connectors act as one beam elements, which solve extremely fast, and they also provide additional information for the shear and axial force. Now that we know the setup we're going to use, we can hide the other parts in the assembly, including the fasteners. Autodesk Nastran is fully embedded in Inventor. You will see the Nastran tab in the ribbon, as well as the FEA browser for making it easy to set up the analysis. Let's create a new study. There are several solver options for efficiency. We'll add the
Okay, I will jump a little bit in the video. Maybe some pictures here. I don't want to take too much of your bandwidth. Yeah, you can see finally there is an analysis. Yeah, don't worry, the interface looks a little bit different. I think this video even was made in even earlier version of the software. Yeah. That's efficient modeling, and then linear buckling, the concept of buckling.
Welcome to this demonstration of
All right, now you can see the assembly even getting larger. This looks like some form of fruit picker or some sort of lifter. Yeah, so
loss in stiffness due to compression.
Yeah, so analysis, they have meshed it. I'm just skipping. You can look at the component itself and then the whole component under analysis, whether it buckles or not. Fatigue. Yeah, fatigue is mechanical loading that is repeated in
Welcome
the
to this
cyclic motor.
demonstration of using Autodesk Nastran.
So in this case, the video front fork of a bicycle, I think, together with a brakes and some form of damper. Yeah, so they worried about this particular particular component. Yeah, so they want to analyze this particular component in terms of fatigue and so on and so forth. And this one is non-linear. So there are analysis. So far we have done only linear static analysis. There is also a analysis option for non-linear situations.
Welcome to this demonstration of using.
You can see here is an actual product. It looks like some sort of a cutter, electrical powered cutter. Maybe you want to cut some sort of shrub or plantation plants that you want to cut. So here is an actual component. Yeah.
The Autodesk Nastran InCAD solver embedded in Inventor of the design to define the behavior of the.
I think in this case they are concerned with the cover itself, yeah, to protect the hands of an operator. It's a plastic cover, so it's a non-linear static analysis. There are some more steps, and then you do the analysis, and then you look at the stress strain. And the next one is non-linear transient response. So in this case, is some sort of material, contact, and large displacement and then and so on and so forth.
Welcome to this demonstration.
Now the assembly even complex. The whole assembly line looks like an assembly line. Yeah, somebody has for this project. This is what you're going to do in your work life. Yeah, so it's an actual component rather than just a single beam or academic example. So they reduce, I think, some sort of filling station.
Portion of the subset is made up of a vacuum system that lifts the cups by the lid and transfers them to the box.
Yeah, some sort of assembly unit. So there is a cage or platform that need to be analyzed. Yeah, so and so on forth. And then finally, you can look at the transient response of the component. All right, so those are what we need to do this week until Monday. New user quick start and essential skill video. Links already been provided in the chat. If you look at it, new user quick start, linear static stress analysis of welded steel hanger, and then you need to do the watch the video for overview and so on and so forth. Yeah, so that is as much I want to explain during the online session. All right, I open to question and answers. Hello, anybody? Please introduce yourself. Okay. Test one. Probably 3 weeks from now. Week 7. Today, this week is week 4. Yeah, week 4, second lesson. We normally have 2 lessons, Tuesday and Thursday. So today is Thursday, week 4. So week 7. Does that answer your question? And then it will be not a separate session. It will be during the class. During the class, it will be a written type of questions, and most of the answers are in the tutorial links that I have given so far. You don't need to find books, things like that. You don't need to expend more money to find books or things like that. The problem is that it's an open book questions. If you don't read the tutorial and the explanation early on, it's going to be very difficult. Yeah. And then also this one, user guide, essential user guide. Yeah, tutorial, overview, this part as well. Yeah, the user guide, fundamentals. Yeah, this one. Share. Any other questions? Hello.
No, sir.
Oh. Okay. I'm not going to take away your bandwidth. We are aware that when you use online session like this, there's a lot of data transferred. It costs a lot of money for you to continually to be on for 1 or 2 hours. Yeah. So I will stop my recording at the moment, yeah, to conserve. So a lot of the things that I've explained early on, you can watch the videos later on at your own time. Yeah, so I'm going to stop recording now. Alright, any more? Tak ada apa-apa soalan lagi ke atau ni? Janganlah pergi ni, boleh pergi makan sekejap boleh lah, saya okey. Tapi janganlah pergi apa mengayau pula ke apa. Ada kelas pukul 10 ya. Kelas lain lah kan. Halo? Tak ada siapa-siapa. Ada kelas
Yes,
kan.
sir.
So siapa yang tak makan lagi tu pergi makan dulu ya. Sambil-sambil tu tengok video yang saya bagi tadi, link apa semua baca, dan juga the linear static hanger analysis tu ya. Boleh Cik Muhammad Amir?
Yes, sir.
Awak dah pergi buat yang propeller tu tak apa, tinggalkan dulu yang tu dulu. Buat yang linear static welded hanger.
Yang hari ni, sir.
Ya.
Sir, saya nak tanya yang buat kira secara manual tu kan.
Ya.
X dia tu nak ambil kat mana?
Oh, mari kita tengok. Siapa tu?
Cik Amir, sir.
Cik Amir ya. Di mana ya tutorial self training section 2 cantilever beam. Apa yang awak nak tanya X tu dalam gambar ni?
Dekat formula dia tu, sir.
Ya. So
Ya.
formula ni dia dah bagi formula ni, jadi awak kena derive the formula.
Derive pakai maklumat yang dibagi ni lah.
Kalau pernah buat bending moment diagram ke atau ni, dia boleh buat yang ni equation ni. Bending stress.
Okay.
Ya. Jadi X ni maksudnya X ni lah kalau sini 0, sini 0 lah, kalau sini X equals to 10 lah. Faham? Ya.
Sir.
Okey, ada soalan lain?
Saya ingat ke dia ambil X daripada beam yang kita buat dalam apa? Inventor tu.
It's the same lah sebab dalam inventor kita try guna 3 elemen. Shell element, solid element dengan beam element. It's the same thing. Yang ni manual calculation.
Okay, sir.
Yeah. Moment of inertia boleh explain Cik Amir?
Tak boleh sih.
Tak boleh. Kena buka buku balik lah. Tak apa. Cuba. Computation by manual lah, by hand. Alright, other people? Let me just check today attendance ada 25 orang. 25 orang. Ada a few name tu saya tengok macam tak pernah update gambar ke apa ke. Fauzan Faris? Halo, Muhammad Fauzan Faris. Dia kadang-kadang login saja, lepas tu orangnya tak ada. Minta maaf lah ya. Tak boleh macam tu. Kalau login kena ada lah depan tu, sama ada saya terima sajalah kalau login pakai komputer boleh, pakai PC boleh, laptop boleh, pakai tablet boleh, pakai telefon pun boleh ya. Tak ada masalah sebab kita tak ada ni. Fauzan Faris, jangan login lepas tu awak pergi tempat lain tu, itu masalah ni, bila panggil nama tak ada. Halo Fauzan Faris? Okey. Itulah ya, jangan buat macam tu. Siapa lagi? No Atira Husna.
Yes, sir.
Saya ada nampak awak ada update gambar dalam team ya. Apa saya tulis di situ?
Shear force.
Dan bending moment diagram kan? Can you explain that? Can you answer that? And the rest of you, siapa yang saya tanya soalan dalam chat tu, sila jawablah. Ya, itu proses pembelajaran. Seolah-olah macam kita bercakap macam ni lah. Kadang-kadang kita nak bercakap, suara tu tak apa-apa dengar, mungkin bising background. Jadi boleh tulis dalam tu ya, Nur Atira.
Okey, boleh.
Itu adalah proses pembelajaran lah. Pelajar kena bertanya kepada pensyarah akan cuba jawab macam tu ya, ataupun pensyarah bertanya soalan, pelajar kena jawab lah barulah belajar. Okey? Muhammad Fauzan mana Muhammad Fauzan? Attendant dah masuk dah ni. Awaknya orangnya mana? Ke speaker. Kalau speaker awak tak boleh bercakap, cuba tulis sikit. Ada tak orangnya? Fauzan?
Kantor itu login aja.
Janganlah cakap macam tu. Mungkin dia mungkin dia speaker dia. Ni. Tak apa ya. Jangan ni. Apa tadi siapa ya? Fauzan ya. Fauzan. Ya, Fauzan, please reply. Yeah. If not, reply during the chat. Let's just check one more person. Saya Lukman Fadli Fauzan Syabuddin Syami, Muhammad Syami bin Muhammad Azmi. Muhammad Syami. Hello Muhammad Syami. Hello Muhammad Syami. Ada sir. Okay, fair enough. Yeah, maybe you cannot open your microphone. It's okay. Okay, make sure you follow the class ya. Syahmi. Okay, always follow the class ya. Always follow our class. So this is zaman dah modern. Kalau dulu kita belajar dengan Tok Guru, betul-betul sampai bersila depan Tok Guru.
Sir.
Ya. Ya saya. Siapa tu?
Wafi.
Ya Wafi. Ya sila.
Okey, sir, macam contoh kan yang kita buat tutorial tu. Okey, lepas dah habis dah semua tu kan. Contoh macam saya ikut follow tutorial 1 dengan tutorial 2 tu kan. Kadang-kadang the form tu max dia tu kadang-kadang tak accurate macam kita buat tu.
Betul. Ya. There's some issues ya. There are inaccuracy to comes various reason ya. Unless I have a look at your model whether you have put the load properly or the value, maybe units, and one more thing, between computers, OS dia pun dia ada tukar-tukar sikit. Dia ada number dia. Later on when we go to self-paced training in the ada satu komponen nama some sort of a yoke like that, we will address how we want to determine the accuracy, how we can increase our confidence level about the accuracy. Yeah. Afi?
Tu yang apa ni? Itu ada saya yang first saya suruh buat backfitting tu, saya macam salah sub case 1 tu max dia ada tak sama dah. Lepas tu saya
betul.
Saya betul tu saya dah follow dah. Dia tak sama, saya buat padam. Saya ingat saya buat tak betul dah.
Tak apa. Sebenarnya proses buat
yang tak accurate lah.
Ya. Buat padam tu is a process ya, macam kita belajar basikal lah, jatuh bangun ya.
Saya tengok macam contoh kan, kalau dalam tutorial tu dia tulis 0.399 kan, something kan. And I dapat 0.38 yang tu saya.
Ya, betul. Okay. Dia ada isu antara OS komputer tu, dia ada floating point ni. So later on we will address how we want to narrow down our confidence level about the accuracy and how to check our model.
Okay, understand. Thank you, sir.
Okay. Tak apa Wafi, buat padam tu is a training, is a pembelajaran. Buat kesalahan apa semua tu is a proses pembelajaran. Okay, pelajar, students, I have to leave the session. As I said, please continue with the lesson on your own pace. As we are trying to do this with online, it will take up too much data. Alright, I will bring this session to a close. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera.
Waalaikumsalam, sir.
Waalaikumsalam.
Thank you, sir.